Hello, everyone. Welcome to the Y-Axis Pod. I'm your host, Tristan Yver, and today, as my special guest, I have Austin Federa. Austin's been a friend for a long time. He's the co-founder of DoubleZero. He used to lead strategy at Solana. He's worked at validators in the past. He has a very historied time in this space that we all enjoy together. So it's great to have him on. Thanks for coming on, Austin.
Hey, thanks for having me.
Yeah, good to have you on. I mean, I've spoken to you in the Solana capacity, so it's good to speak to you in the capacity of founding a company, of building something yourself. I think that's very exciting. And generally I would go into your story, what you're up to, but I think DoubleZero is so interesting and new that it might be good to unpack it a little bit so people
Sure.
get a sense of what it is you guys are building. I think the tagline that stood out the most for me in the white paper was a new internet for distributed systems. And I'd love to hear what that means and what you guys are building.
Yeah, so the internet is a great thing. We all know and love the internet, but the internet was never designed for the way people are using it now, in either the centralized or the decentralized capacity. So in the original vision of the internet, it was very much designed as one point to one point connectivity. And it's really good at that. You can reach a server anywhere in the world in a very short amount of time and get some amount of bandwidth and connectivity into them. What it's not designed for is the thing blockchains do every day. I've produced a bundle of data in one location and I have to get it to 3,000 other locations and I have to get it there as quickly as possible. And then I have to do that again and again and again and again. And this sort of multi-party consensus where you're sending one amount of data out to thousands of other locations, the internet's actually really bad at this. And the best example of why and how the internet's bad at this is it took us like 15 years to figure out how to stream the Super Bowl. We can still barely stream the Olympics. And this is because, like, fundamentally on broadcast television, if you're tuning into a satellite or you're tuning into a cable, through cable coax or over the air broadcast, the number of people watching that broadcast doesn't put any additional strain on the person sending it, right? This seems obvious, but like 1 million people can listen to the same FM radio station at the same time, and they still just need one transmitter putting out a bunch of radio waves. That is not the case with the internet. If you have 1 million people trying to watch the same live stream, well, suddenly you need 1 million times more bandwidth. And there's some clever things people have done that mean it's not exactly a one-to-one multiplication now always, but fundamentally each additional watcher, or in this case, each additional node, is a burden and a tax on the system. And you see this today on high performance networks like Solana, where when it's your turn to build a block, you need multiple gigabits of upload data just to propagate that block data you've produced out to everyone else in the network so you can reach consensus so the network can keep moving again. You see these like, oh, it's using a little bit of bandwidth, it's just taking in the blocks of that other people are building and voting on them. Oh, it's my turn to build a block, and then it goes way back down, right? And that's because we're trying to, like Turbine, which is the way Solana propagates blocks out, or RaptorCast, which is the same thing on Monad now, or the new thing that Base is using that I forget the name of, Flash blocks, maybe something like that. That's all derived from the same technology that Solana's used, and Solana's technology is basically a attempt to implement a technology called multicast on a network that doesn't support it.
One thing that may make sense, Austin, is to touch on why that block is being propagated to all these nodes
totally.
The network, and why that makes it a decentralized system, essentially.
Yeah, totally. So in the traditional version of the internet, you were just sending a packet out to a server, and the server was responding and sending you back some data. This might be like a Google query as a very simple version of it. And in a centralized system, we just trust Google. I just trust Amazon that the price on the website is the price that's going to happen. When I load something on a traditional system, it's a very hierarchical model. And that works fine on the internet. But the minute you move to a distributed model or a decentralized model where suddenly everyone around the world has to agree that all these state transitions, all these transactions in this block, they did actually occur. If I do the math, I get the same answer that Tristan did when he did the math. That requires me to have all of that data. And so you can see a lot of these trends over the year that prop up in blockchain that are all kind of trying to come at that same fundamental problem in different ways. So the problem, just to be really like blunt about it, is we got to get a lot of data around the world very quickly, and that's hard to do. And so you see two trends in the industry right now. You see a shrinking of the validator set, right? I mean, you can go back as far as you want with this. There are way more Bitcoin miners than there are Ethereum nodes. There are way more Ethereum nodes than there are Solana nodes, and there are 100 times more Solana nodes than there are Hyperliquid validators, right? And so we see this kind of consolidation because the easiest way to make a distributed system more performant is to shrink the number of people involved in it. Because you take that problem of 1 to 2,000 and you bring it down, 1 to 200 is a lot easier. 1 to 2 is a lot easier. Eventually, you just get back to a centralized system where you have a one-to-one relationship. And that is the centralized exchange, right, at the end of the day. The other trend that we see is a lot of compression technology applied, but there's a lot of downsides to that. So the movement for ZK proofs is not because you get some privacy preserving technology, although you can use zero knowledge system for that. You get something called succinctness, and succinctness is basically just compressing data in a way that it is now, you have to move less data around the world. So in theory, you can run the systems faster, but the provers are super slow. And so it doesn't actually necessarily speed anything up. And so our approach was basically, what if we throw all that away? We can still implement all that technology if we want. But the fundamental problem here is that the internet was not built to do this. So what if we just try and build a new internet? What if we try and build a parallel physical fiber network that can use the latest and greatest technologies like multicast, which is a way that you send a packet once and it gets everywhere it needs to go. You never have to worry about it. And build this thing optimized for distributed systems and take a lot of technology that's existed for, 1 or 2 or even sometimes 3 decades in the high frequency trading world and try and apply that to an open access democratic system. And that's where the idea for DoubleZero came from.
That was my follow-up question, actually. So you have this networking problem you're working on solving. You have this entire, let's say, network of people who have undersea cables, terrestrial cables. They have them in all these different places. You will work with these people to have designated bandwidth for the DoubleZero network within their infrastructure. Is there also a hardware component for DoubleZero, or is it purely just having this private network to work with?
Yeah, so let me restart this. So at some point, it's very hard to separate what is hardware from what is not hardware in the system. So if you think about what are the engineers at Melbeck Labs and DoubleZero Foundation doing day in and day out? They're building software, right? At the end of the day, their main product is a software package. However, the network doesn't work without the physical fiber contributors. And so there are, right now we have 5 independent contributors that are all contributing slices of a global trading network, basically a global fiber network. And so there's 2 components that work together. So first we need the physical fiber, which is extremely expensive to install if you're running across the oceans or something like that. So what'll happen is these companies will go out and they'll run fiber cables, let's say across the Pacific Ocean. And you might think there's 10,000 strands of fiber that go through that. We think of this big, thick cable that's got just a mess of fiber in it. Most of that is armor, it's data, it's power, it's all of this stuff you need to support a 6,000 mile long cable run, basically. Inside of it, there's maybe 8 strands of fiber. There's 8 pieces of glass that are run from...
That's crazy. Because how thick are these things are thick, right? I think I saw a bisection photo of it once.
Yeah, so it depends where. So in the middle of the Pacific, they're actually not, they're about as thick as your arm, right? They're not actually terribly thick in the middle of the ocean. But when you get closer to land, they can be quite thick. And that's because they add all this armoring. So if a ship anchor drags over it, it hopefully doesn't rip all the way in and damage the fibers. Maybe it just damages the casing, all these sorts of things. And then they basically, it's delightfully medieval the way that they do these things. They basically drop what is effectively a giant plow off the back of a ship. And it just literally lays the cable under the sea floor. If you've ever seen how farmers plant seeds, it's basically the exact same thing, just dragged behind a ship as opposed to a tractor. And instead of putting seeds in the ground, it's laying a cable. And like that's how they get these cables back like onto land. And so there's a huge amount of obviously capex and opex that goes into making this stuff possible. And so even, cables that are installed by like a Facebook or an Amazon or something like that, they have some component that they lease out to other providers because it's a way to help reduce the cost of these things. And so the majority of the contributors to DoubleZero Network don't actually own fiber themselves. What they're doing is they're doing the thing that almost all companies do, where they lease fiber. The same way you can, lease any type of like most companies don't own their manufacturing plants. They lease the building or something along those lines.
Yeah.
And so, the first step is we have to get access to the fiber. And the second one is you have to run these basically high performance switches, which, it was funny. I was talking to Andrew, our CTO co-founder about this. And I was like, oh yeah, we put these like really expensive switches. He goes, no, these are not very expensive switches. I'm like, they're like $40,000 each. He was like, that's not actually that expensive in the world of like carrier grade networking equipment, which was like a very funny thing. Because like, to us,
what is a switch, Austin?
So the switch basically sits at the end of each piece of fiber, and it manages the data coming in and out of that piece of fiber. And so in the case of DoubleZero, that switch actually does a whole bunch of stuff. So one of the things is it does packet replication. And so this is what we were talking about with multicast, where if I'm a validator, I can just send the block once, and the network will in hardware accelerate and replicate all those packets and get them to where they need to go. The switch also manages things like, is Tristan's validator, has it actually paid for access to the network, or is it trying to freeload off of it? If it's freeloading off of it, it sort of shuts down the connection. And so there's all of these.
Question.
Yeah.
So that replication happening in the switch happens there because it's a lot faster and cheaper to happen in the switch than any other modality, or what's the
So we sort of forget that CPUs, the x86 chips we see inside all these validators and computers, they're general purpose devices, and general purpose devices are always slower than purpose built devices. They can do a lot more stuff, right? You can't run Doom on one of these switches. But like when we're talking about things like taking one packet and making 20,000 copies of it and sending that data out and making sure it gets to where it needs to go, this is basically implemented in hardware or very low level software. And so it's the same reason that you can't mine Bitcoin on your laptop. You've got to go buy like a purpose built machine for it. Or we have graphic processors for games that are different than the normal processors you use for stuff on your desktop. And so
does this reduce the requirement for doing that computation within the validator servers? They
massively.
Kind of like offboard it to you guys? Oh,
yeah, exactly. So there's two major pieces of compute that we're offloading. The first is on replicating, because you think about it, like if right now if I'm a Solana validator or a Sui validator or any validator, I'm sending out copies of the data, and if I have to get that to 200 places, I have to go, here's yours, here's yours, here's yours, here's yours, 200 times. And computers are very good at doing things quickly, but like time really matters. Like there's 400 milliseconds to produce a Solana block. That's actually not that much time when you consider it takes 250 milliseconds just to get to Singapore and back. So any delays in sending out data can prevent the whole network from advancing and moving forwards. The other thing that the DoubleZero network does with hardware acceleration is it does signature verification and transaction deduplication. And so this means that all of the potential transactions coming into a validator, there's an FPGA, which is basically a field programmable gate array. It's basically a hardware chip that can be reprogrammed on the fly. And it's doing signature verification. It's basically saying this transaction's been submitted. Does all the math work, or is someone trying to fake this transaction? Every validator today has to go through and validate all the signatures on transactions, because if you include a transaction that has invalid signatures, the rest of the network is going to reject it. They're going to get the block and do the math and be like, wait, this math doesn't work. There's something broken here, and reject the block. And so if you produce a block with bad signatures, in some networks you get slashed, but on every network you don't get rewards for that block. And so you don't get paid for it. And so there's a lot of incentive not to include bad transactions in it. But that takes a lot of time to do the signature verification. Like something like 50% of a validator's time is just spent sorting through the insane amount of volume of inbound transactions to find the good ones that are most profitable that it wants to include in the block. And so we can basically throw out all the garbage in hardware beforehand. And so we take a pool of maybe 100,000 potential transactions and we shrink that down to 10,000 potential transactions because we throw out all the stuff that's just like, and I don't mean spam like it's low economic value. I mean like genuinely, there's no way you could ever include this transaction because it's malformed or it's just a duplicate of another transaction. And so we give the validator back a bunch of time, which means it can produce a more profitable block, or can, run MEV. There's all these other things the validator can do now that it has more time.
Yeah. And so as part of this all makes a ton of sense, and that's actually really exciting, especially because it's all a time game here, as you said, and the more time you have, the more capacity you have for better economic outcomes. But does that mean part of the work for DoubleZero is integration into the blockchain so that it accepts the signature validation you guys are doing? Or how do you guys talk to like the Solana blockchain, for example, in that regard?
Yeah. So this is actually a great question because we call these things layer 1 blockchains, but they're not layer 1 blockchains in like the OSI computer science view of the world. They're like layer 5 blockchains, right? The OSI stack has 7 layers. Like everything that happens in blockchain is actually very high up the stack from like a computer science perspective. And so what we are building is a layer 1, 2, and 3 network. It's way below that. Like it's the physical cables in the ground. It's the software transport protocols and stuff run on top of. And so in some ways, like the Solana network doesn't know it's running on DoubleZero unless they make use of all these optimization technologies. Like if you're running a validator today and you're running it in TerraSwitch or Latitude or Equinix or something like that, the validator has no idea like, oh, I'm using the TerraSwitch network. I'm using, Equinix Fabric in order to communicate. It just knows like pack it in, pack it out. Like I guess things are awesome. And so on the most basic version, you can actually move the existing software clients and existing software packages to DoubleZero, and you'll get a bunch more performance just because the underlying network is faster. But there's other work we're doing with like the engineering teams at FireDancer and at Anza to support technologies like multicast, which the validator client does need to be made aware of. The good news is this technology is like pretty pervasive in the professional high performance networking world. And so it's like, it's just this funny thing Tolly always talks about like, is this computer science or is this just work? Like just work is stuff that we fundamentally know how to do, but we've got to assemble a bunch of software and there's a ton of implementation details in it. But like a great example of this is like, we know how to build a skyscraper. It's just work to build a skyscraper. We do not know how to get a crewed mission to Mars. Like there is true, real research level science that's to go into making something like that possible. Whereas like we can build incredible mega projects and structures and there's real skill that goes into it, but it's just work. It's not like R&D science and technology. And so most of what we have to do is just work, because there's so much technology out there that supports it. Now, it's never been adapted and applied to blockchain. And so most of what we're doing is actually taking technology that assumes there's a central authority and removing the central authority, which is exactly the way Bitcoin started too. If you think about it, like all this encryption technology that like Bitcoin uses, it was all originally designed to say, how can I trust my connection to a trusted server? Not how can I not have to trust that server at all. And so we're kind of going through a similar transformation to what compute has gone through over the last 10 years, but we're now applying it to networking and network data flows.
So before I ask some more specifics on how this works and whatnot, tell me if my sort of list of potential partners / customers is right. So you'll work with validators. You'll work with RPC providers. You'll work with infrastructure that wants to permit faster, better, whatever it is they're trying to do with their infrastructure. You'll work with blockchains themselves and then perhaps MEV operators as well.
Yeah, that's kind of the initial blockchain type use cases. There's a few others that come up, like indexers, because they also need to track the state. And then there's the ability for things that need to do work on state. So you can think like a zero knowledge proving network or something like that could also operate on DoubleZero. But then there's a whole other category of like, I would call them like very specific types of blockchain work. So for example, a storage network has a very similar problem to a blockchain. Like I've produced a block, I need to get it out to 2,000 nodes. Well, I've just ingested 10 terabytes of data because I'm Filecoin or Arweave, and it's great. It's on my server now. I need to get it out to enough replicas around the world that like it's actually backed up and people are paying for that decentralized storage. And if it just stays as centralized storage, it's just really expensive Amazon S3 at that point, right? And so there's a lot of applications for like, to go back to kind of the core thing, like most of what we've been talking about today is how the internet's bad at moving data quickly. It's also really bad at moving large amounts of data. So if you need to move like, a YouTube amount of data around, you don't use the internet. Like hilariously enough, there's a product Amazon sells, or sells is a kind of complicated word here, but that they have called Snowball. And Snowball is basically a entire semi-truck that'll show up to your data center with a bunch of fiber connections, and you can hook up like terabits and terabits per second of data transfer. Mm-hmm. So you load your data basically onto all these hard drives in this semi-truck, and then that semi-truck drives and backs into an Amazon data center, and they pull all the data off of it because it's literally faster to drive a truck full of hard drives like across the country than it is to try and use the internet to transmit that much data back and forth. Which is like a hilarious, dumb, like you've probably seen these jokes that people make a long time about how like one of the fastest network transport protocols is just like tying a 2 terabyte flash drive to the leg of a carrier pigeon and sending it off to a data center. And like from a data transfer per second rate, that's super fast. Now it's obviously not like, useful, but this is just like kind of to illustrate the example of like, it is actually pretty hard to move huge amounts of data over the public internet today. Let's say
that data that the Snowball truck pulled up to was actually a DoubleZero customer. What would the interaction look like for them if they wanted to do the same thing?
Yeah, so the network we're building out at the moment is primarily based on 100 gigabit network links. And so you can sort of do some math around what that looks like. But if you were saying, I want to get, let's say, like I'm Filecoin or something, and I want to move like petabytes of data from, one node to another node. Right now, that's a very slow, long process for that data to all sync up. But if it's running over the DoubleZero network, it has like direct full speed connection because this is all dedicated fiber. It doesn't have to compete with other traffic. It doesn't have to worry about getting stuck in routers and like, all these types of things you run into on the public internet. And so you may have that sort of data stream. Sometimes it's running at, 400 gigabits per second. Sometimes it drops lower depending on other demand on the network. But it's sort of like, I would describe it as like the difference between like having a private driver and relying on Uber. Uber's great a lot of the times, but like sometimes it's raining and you just can't get a car, or the cost of a car goes from $40 to $120 because a lot of people suddenly are like, oh, it's raining, I don't want to take the subway. And so it's the exact same thing here, where if you have dedicated resources and you have allocated resources, you don't have to worry about these kind of demand spikes and all this type of thing. And that's part of why transferring data on the public internet is hard, is it's very unpredictable. And so really what DoubleZero brings is a determinism and a predictive, very predictable model of how data moves, both from a latency standpoint and a capacity standpoint. This is the whole thing about increased bandwidth, reduced latency. Like we're doing both of those things compared to the public internet.
And is the reason for this to be a decentralized, distributed company / project because that allows you to tap into many different providers' segments of fiber versus having to build your own? Or what are the trade-offs that make it worthwhile to do it as a distributed company?
Yeah, so we raised $28 million, which is a lot of money in software and is very little money to build a cable system. And so There's sort of two reasons to build this as a decentralized company. We could have built this as a fully centralized, vertically integrated company with no token and just gone out and taken a bunch of network leases. But there's kind of two things that go into this. The first is the problem we're trying to solve is solved by blockchain payments, right? It is the idea of to take a step back for a second, weirdly, private networking is not a network effect business. If I'm jump trading and I put in a network link between London and New York, it doesn't do anyone else any good. In fact, I actually don't want it to do anyone else any good because it's my competitive advantage, right? So all of this private networking capacity that's been run everywhere, it doesn't help anyone else. It's the classic idea of like if we all own a car and park it on the street, 99% of the time that car is going nowhere. If we could just magically share cars, like everything would be much cheaper and much more efficient. And you can apply the same problem to networking, right? We have all these companies that have these private network lines, but maybe they don't need all the capacity. Maybe they just need some of that capacity. And so they can contribute a slice of that network capacity to the DoubleZero network. They can earn tokens in exchange for doing it. And it's all cryptographically assured that this is indeed what's happening, right? This is actually the only network where you have guarantee of packet delivery, or at least you have traceability of packet delivery. Now, if we'd built it as a centralized company, apart from just the problem of like, a blockchain protocol is actually the perfect, most fair, lowest overhead way to distribute rewards among contributors of the network. There's also the problem of, would anyone trust it? Like, if this were run just by me and the engineers at Malbec Labs and, Andrew and Matteo, there's kind of the Nakamoto coefficient then is basically 1, right? We would have control over the network. We'd have a big red button that could say stop. Someone could subpoena us and we'd be like, sorry, guys, like we don't want to go to jail. We're going to shut down the network, right? That's not the type of system that we want, right? What we want is a system like Solana, like Ethereum, where Vitalik does not have an off button. Anatoly does not have an off button. Like these players in it, even if they're important individuals, they don't actually have operational control over the thing. And so it may surprise you, but there's kind of only 20 companies that run the internet. Like there's 20 tier 1 ISPs out there. And if they collude against you, like, good luck. Also, like, if you're in the United States, you probably have one company that provides you internet. You can't go buy it from anyone else. So if Verizon's like, hey, we don't like Ethereum anymore, like, good luck, home stakers. It's not going to matter.
Is that just because we've had the same dynamic as the banking industry where it's just all consolidated into a few winners, or there were just very few who had the cap X to be able to build these things?
So it comes out of the fact that the internet was not ever thought to be valuable when it was getting built out. So it was sort of like a side business for all these like phone companies, basically. And then it became a huge, big thing over time, right? And so there's a whole bunch of reasons that like there's all this weird stuff. Like we were going through and buying like a bunch of IP addresses for DoubleZero, which is like something that's kind of weird to think about, but there's not actually that many IPv4 addresses out there. And so we had to buy like 30,000 of them. And I was talking to Andrew and I was like, this is kind of like a very arcane process to like buy IP addresses. He goes, oh, up until 2 years ago, you had to fax in your order form. And I'm like, are you kidding? Like the companies that run the internet only accept faxes? And he was like, yeah, like this used to be a thing where like you'd have to get a wet ink signature and then fax it in and mail them back a copy of it. And it's just like any other industry that hasn't faced a lot of disruption, that was sort of built a long time ago, and sort of, it's one of these things like we think running the internet would be like a super profitable business. It's all fairly low margin stuff. Like it's attractive to like private equity firms and stuff like that, but you're not getting 71% profit margins on like running a fiber business the way you are running like a cloud business or something like that. And so part of this is like, it's an industry that is kind of ripe for disruption, but also hasn't really successfully captured much of the value that they create either. And so that's kind of like, Austin, yeah.
So I think that was just a perfect note to talk about the different steps of DoubleZero capturing that potential value and how the different paces or steps of this rollout will look, at least as if you're thinking of it right now.
Yeah, so we have a testnet up and running at the moment, which is pretty awesome to see. Honestly, it's much faster than I thought we'd get this thing up. But if you think about kind of the value chain here, there's folks who are users of the network, which is again primarily validators, RPCs, professional traders, like the infrastructure class you could call them in crypto today. And then you have the supply side, and the supply side are, it's Jump, it's Galaxy, it is Rockaway, it is Distributed Global, it is Latitude, it is TerraSwitch, it is the folks who run physical infrastructure today. And so what we need to do is figure out a system where validators and RPCs are paying to use the network, and then the bandwidth providers are getting paid for providing bandwidth. And historically, this has all just been a flat USD monthly fee. But that doesn't really incentivize innovation. It doesn't have shared upside. It doesn't actually make people build better networks or anything like that. And so our model's kind of flipped on its head, where validators will divert a percentage of their earnings. 5% is the number we're starting with here. And that will basically go to buy DoubleZero tokens. And then about 50% of those tokens are burned, and the other 50% are distributed out to bandwidth contributors as rewards. And there's a whole Shapley value formula that goes into determining what that reward rate is on a specific network link. But I think it's really important that, like, one of the things blockchain has been historically very good at are win-win upsides. That, like, if you have a DeFi protocol and, like, the price of SOL goes up, you benefit from that price appreciation, even if you don't necessarily own a bunch of SOL, because the trading volumes go up, the trading fees go up, all this type of thing. And so we have basically got the first network system where bandwidth providers get a cut of the economic activity that's transiting over their network. And this wouldn't fly in the traditional space. And it wouldn't fly in the traditional space because it's all one point to one point. Like, the New York Stock Exchange is not moving around every few days. It's always in the same spot. That's not true for validators. Validators move around all the time. Like, no single company could go out and wire up all of the data centers that Solana validators or Sui validators or Aptos validators or whatever validators are running today. It would just be way too expensive to do. And so the network adds value over the value of each increment link. And so one of the core unlocks that we have is this sort of idea that, like, bandwidth providers, like, they make more money when the networks are more profitable. And that's kind of like, it breeds this great competition, because now every network provider, instead of saying, well, I get my $30,000 a month in dollars from this, it's like, oh, if I can eke out 2% more performance, I'm going to get tokens. And I think those tokens may be more valuable in the future. So I'm going to put a lot of effort into eking out that extra performance. You see this with MEV really well. Like, the amount of optimization of, like, where is my validator to optimize JITO rewards and these sorts of things? People move data centers for like 10 basis points of additional yield. Like, we have created a economy that's hyper focused on extracting, not in a bad way, but like extracting as much value as they can, making the most performant compute infrastructure. And I think we can do the same thing on the data transport side. And the goal of this is to make Solana able to run 1 million transactions per second on mainnet, and then roll out and support other validator networks in the future as well.
Okay, talk to me about that, about the IBRL. How does using you guys specifically allow for faster transaction, for example, or more transactions in less time?
So if you saw the demo at Breakpoint last year of a Solana testnet cluster on 4 continents with 6 nodes running 1 million transactions per second, that was actually running on the DoubleZero network. We didn't tell anyone because we hadn't announced the project at the time. But that was like the alpha version of the DoubleZero network. And
what is happening there?
Yeah, so basically what's happening there is, instead of using the public internet for consensus and block propagation and all this stuff, it was using the dedicated fiber of DoubleZero. And I have to kind of explain some concepts to like get to why this is cool, but there's 2 main concepts here. One is latency, and the other is jitter. And if you grew up in the 90s and 2000s playing video games, latency is just ping time. It is how long it takes your computer to talk to the server and then the server to talk back to you. And if you're playing a first-person shooter game like Counter-Strike or Fortnite, you live and die by your ping time quite literally. Jitter is a measurement of basically how consistent that ping time is. So if I'm pinging your server and it's always 100 milliseconds, I would have an extremely low jitter. The average amount of time it takes is very, very consistent. That is not true in the public internet at all. The average ping time can go, especially when you're moving across an ocean, it can vary by over 100%. And so this causes a real problem for high performance systems. It suddenly means that if it might take 400 milliseconds for me to talk to you or 2 seconds for me to talk to you, I suddenly need a much bigger buffer and a much bigger window. And then I have to store all that data and then put things together out of order. It just makes everything a mess. It's sort of like if you're trying to oh God, there's so many.
No, I totally get it. It's like if you're trying to create code that works in a consistent manner across time, you want to be able to have parameters within that code that are consistent. If not, everything's just not going to work.
It's like reading a book out of order. You'll get the plot, but it's going to be a pain in the ass, And so that's kind of like the approach here is when we use DoubleZero, we have extremely low jitter, basically zero jitter, because that's all caused by packet queuing and delays in routers and switches on the public internet. Because you'd be surprised, but if you're in Japan right now, right? I'm in New York. So if our data back and forth over Riverside here, it is probably transiting through 20 or 30 different network switches and 20 or 30 different hops before it actually gets from my computer to your computer. And what that means is that there's, in each of those locations, if there's any little bit of delay, if suddenly it's like merging on the highway, right? No matter, even if there's enough room on both sides of the lanes, there's slowdown that happens whenever you have a merge. The same thing applies to packets moving across the internet. And so
yeah, I mean, you're blurry as fuck right now, so I believe it. I see the need for DoubleZero as we speak.
I tell you, man, every time people are like, explain to me why we need DoubleZero, I'm like, well, how good is your Zoom video? And
I'll send you a screenshot so you can see it after.
It's entirely as simple as that. It's pretty funny.
Okay, so you guys recently announced the token in a small sale or perhaps large sale, but specifically for validators. I read that they have to sign with a key showcasing that they are indeed a validator, which is pretty new. I've never seen anything like it. It's CoinList's first US open sale in a long time, I believe. Correct me if I'm wrong. What does this first stage look like? Does it give a date for when the token is releasing, or is it just an initial way to connect with the validators you want to work with?
Yeah, so we spent a lot of time thinking about... So I'm going to start off with just I don't believe in airdrops. I think airdrops largely do not work. I think Cheeto did an incredible job with their airdrop, but it's very hard to point to massively successful or even successful airdrops. And I think the reason is that it breaks they're too farmed, they're too sybiled at this point. We have 150,000 people in the DoubleZero Discord. I got to imagine a bunch of those are either bots or just there hoping there's an airdrop, right? I would be very surprised if there's 150,000 passionate DoubleZero pre-launch people in our Discord, right? And so I don't think airdrops are an effective way to build community or an effective way to align incentives. And so, one of the things that Solana did very well in the early days was, and it was totally accidental, was they did this thing that was basically a sale out to validators. And Solana Labs did this because they were rapidly running out of money in the end of 2020 and were literally laying off half the engineers because the network, it just hadn't caught fire. The PMF wasn't there. And so they went out to their validators and said, hey, do you guys want to buy some tokens? You clearly believe in the network. And a bunch of them said yes. And that ended up being, transformative.
Very happy campers.
Yes, very, very happy validators, right? And, what this was basically a bunch of Cosmos validators that took like a bet on the Solana architecture and said, this looks pretty cool. And so, we wanted to replicate some version of that with this. And sort of the most important people for the DoubleZero network success after the bandwidth contributors are validators on these networks, because they have to say, like, I'm willing to pay a little bit more to make Solana 10 times faster or to make Aptos 10 times faster. And so the idea here was like, okay, I don't believe in airdrops, but I do believe in incentive alignment. Can we do something that will accomplish this? And so we teamed up with the folks at CoinList who were willing to build basically a bunch of signing infrastructure where validators could come in, and because it's sort of like that old on the internet, no one knows you're a dog. Like, I have no way to know if you're a validator or not unless I can get you to cryptographically sign this transaction. And so what CoinList will do is they'll link that up to the KYC profile and the account that you've created there. You still have to pass KYC and KYB. That it might be Trump's America, but it's there's still a lot of securities laws out there we got to comply with. And basically, once you pass that process, you can participate in an auction, and it's only open to validators. And one of the cool pieces about that is you're not bidding against a bunch of VCs. You're not bidding against a bunch of whales. There's some downsides of this, which is like a lot of community members aren't able to purchase. But it's you can think of it as kind of like we're going in like oh God, what's his name?
Yeah,
Maslow's priority in a hierarchy of needs, and it's like network operators, validators, and then we move on right from there. And so if we can get a bunch of these validators who are already very excited about DoubleZero to have upside in its success, I think it's the classic win-win economic structure that blockchain has been so successful at.
And we just need to try new models. I mean, one of the reasons I'm excited for DoubleZero, and full disclosure, I am very happy to be an investor as well, is because you guys are building new things. And there is so little of that happening right now that I think it makes it particularly exciting. And also the fact that you guys are willing to try different models like this validator sale, which may work wonderfully, may not work, but at least it's something new, something different from the status quo, which I do feel like crypto is sort of getting wound up into the same spirals right now instead of going into new things. So I think it's quite exciting.
Yeah, thank you. It's been really, I did not expect to get the amount of response that we got for this project. I thought we'd have to go through and spend a year educating people on why networking was actually important. It's a deeply unsexy crypto project. Like, people are like, oh, what are you doing? And they're like, oh, we're like pushing the bounds of cryptography for quantum resistant, hashing algorithms. And we're like, we're building a bunch of fiber so we can make blockchains run faster. And it's not like a particularly sexy topic. So I've been we've all been thrilled and overwhelmed at kind of the response of folks, and a bunch of folks outside of the Solana ecosystem too, being like, this is super cool. We'd love to talk about using this on our L2 or L1 or something along those lines. Cause at the end of the day, DoubleZero is like base layer neutral infrastructure. We're starting out with Solana because it's the fastest network that has a large decentralized validator set. Like, there's a metric no one looks at, which is kind of like TPS per number of validators, right? Which is kind of it's not an idea that's out there much right now, but I think it's really interesting to look at. Is if you think about a decentralization coefficient, is sort of what is your transactions per second divided by your number of validators, and there's kind of some magic there where we should be thinking that a network that has 60 validators is less secure and less decentralized than a network that has 2,000 validators. But you don't want to get stuck in the Ethereum homestaker trap of they have, let's call it 7,000 computers out there running Ethereum, but it does 20 things per second. And so you have a very low utility rate. You're paying a huge amount for security and decentralization for very little performance. Then you have Solana, which is picking a different point on that curve, right? And then you have Hyperliquid or BNB that's picking a very different point on that curve. But you can sort of look at this and you can be oh, what are the mid curve chains? And it's anything where you don't have much decentralization and you don't have much performance. Like, to me, that falls into the mid-curve category. You can either be like Bitcoin, which is like maximal decentralization, very low performance. And then you have things that like, a Hyperliquid, which is like very little decentralization, very high performance. There's a whole category in the middle where it's just like, I'm not sure where the differentiation comes from a bunch of these protocols. But part of the goal of DoubleZero is like, if you run a network now that's like got 100 validators or something like that, you can take that up to 1,000, and you can do it without all of the overhead that you would normally think of as sort of with dealing with the public internet. So I think we can decentralize kind of centralized validator sets today, and we can also make blockchain 100 times faster than it is today. And these are not contradictory ideas. This is kind of the whole like, the trilemma was like a cute blog post, but like it is not governing the limits of blockchain today.
One thing I would love to see as you guys ramp up is a map that lights up the different fibers that you have access to, just so that we can watch as you guys expand to different parts of the world. Do you have that?
Yeah. Hell yeah, we got a big board.
Because it must be so satisfying to just watch new lines light up or appear. I'd be just staring at it. I gotta get more lines on the board.
It's really pretty cool.
Question for you. Initially, as you guys have certain designated fiber lines that you're working on, will the connections only work for validators that are within those geographies, or how will that work?
Yeah, so we use basically a software tunnel to connect the validator in, so you don't need to be physically cabled into the front of the switch. But generally speaking, it's probably good for like 60 kilometers around wherever that point of presence is. And so like if you are in Boston and we have a network link in Philadelphia, that's probably not going to do you any good. But if we have a network link on like one side of Tokyo and you're in the other side of Tokyo, that'll actually probably work pretty well for you. Generally speaking, cities have really good connection within them. But the minute you leave kind of like that metropolitan area, the connectivity quality goes down a lot.
Got it. That makes sense. And is there anything specific that you want people to be paying attention to? Are there any DoubleZero calls to action, or is it more so focused on the BNB side of the world at the moment?
Yeah, so if you run a Solana validator, you can go to doublezero.xyz and you can sort of apply to join our testnet. We'll be moving that to permissionless testnet probably in May. Which is kind of really exciting to see. If you're interested in becoming a bandwidth contributor, you can also find out some information on how to do it there. But one of the major kind of like call to actions for folks is just like, we have to take networking seriously. There's a lot of protocol teams that have kind of just had this like magical thinking approach to networking for years about being like, oh, like libp2p works fine. Like these technologies work fine. We need to focus on compute, and compute is super important, right? No question about it. But we've gotten to a point where the thing holding most of these networks back is not the validator client software anymore. It's not how fast CPUs we can throw at validators. It's the networking connectivity layer. And so if we're looking for sort of like what is the lowest hanging fruit in taking these systems from 10,000 transactions per second to 100,000 to 500,000 to 1 million transactions per second, it is the networking layer. And so it's just getting folks to like, and by folks, I mean like engineers and roadmap planners at major L1s and L2s to take this stuff seriously and think about like, okay, maybe this is a part of the software stack and the hardware stack that we've kind of ignored for a while. And maybe it's time to take a closer look at it again.
So perhaps a dumb question. Let's say you're Perplexity and I'm using you here in Tokyo and your servers are in San Francisco. Would they benefit from giving me faster results to my queries if they were running on the DoubleZero network, or does that have nothing to do with it?
It certainly does have something to do with it, but usually when you're talking about consumer-facing tech, unless it's a large amount of data, there's not a ton of advantage. Like, it's like probably 400 milliseconds to get a response time. That's pretty fast. Like if you're just typing stuff into a chatbot, like that's fast enough in responses. If you're a trader, like Nanoseconds matter if you're a trader. If you are trying to compete with YouTube, maybe it's even a Web 2 service you're trying to build, but you're just like, look, I don't want the censorship. Like, I don't want the ads. Like, I want to build my own creator network. You might want to run a CDN on top of DoubleZero because now it can serve data in local markets. And so there's a lot of other, yeah.
I cannot believe I didn't touch on the censorship topic here about an uncensored internet. This means we're just going to have to do another episode and talk a lot about that because that's incredibly interesting. I'll just do one question since we don't have that much time. Can you provide an uncensored internet that can't necessarily be unilaterally shut down, or is that just not the case in how these fibers work globally?
In a mature state of the network, yes. So one of the things we've been focusing on are alternative pathways into the same city. So Tokyo is a major hub for running validators. There's 5 different network lines bringing connectivity into Tokyo, and they're run by independent network contributors, some of them, and they're run on different pieces of fiber. And so all of the, like, if we kind of think of like, you know, like the peak censorship, like 2020, like craze of like, let's kick Parler off the internet, let's, you know, all these sorts of things. There was never a moment, like they got kicked off of Facebook, they got kicked off of Twitter, they got kicked off of Amazon Web Services, they got maybe even kicked off of Cloudflare. There was never like a call for like, oh, Verizon, you need to literally block these packets from arriving at my house, right? And so the lower level down we get, the more censorship resistant we get. It's the same way that there's no software running like in your CPU that's like, oh, you can't do this math, it's illegal, right? And it's just the lower level down you get, the more censorship resistance you get. And so if we're able to reinvent this base layer, it allows people to build their own vertical stacks on top of it and make their own censorship decisions, right? Like the YouTube censorship problem runs both ways. YouTube, if you have like friends who have kids, YouTube Kids is a dumpster fire cesspool. It's not actually kid-friendly content. It's just a bunch of like, kind of like brain worms for children. At the same time, like if you are trying to talk about something that maybe isn't politically popular at the moment, there is also censorship there. So like you don't get the good censorship of like, I want something safe for my 4-year. Like if I put on PBS, I know Sesame Street is not going to be talking about weird stuff, right? You don't get that with YouTube Kids. And on the flip side, if you want to be talking about things that are maybe less popular, like what were the origins of COVID? Like, do we really think these social programs are good? Like, those are also things that will get you kicked off YouTube, or at least at one point in the past would have gotten you kicked off of YouTube. And so we think that just like optionality is the name of the game, and that people should have more freedom to build different types of experiences, some which are tightly controlled, some which are open access. And, you know, it's sort of like if you want to make a rocket 100 kilograms lighter, the only way you do it is you take 1/10 of a gram off of every screw. And it's that same idea of like, we got to go to the lowest level of the stack and sort of start from first principles and figure out how we can rebuild a connectivity layer that reflects the values that we want in society and the type of software systems we want to see built on top of it. I'm a big consequentialist when it comes to like software architecture, that like the policies and the way we build stuff dictates how those things are used. Another way of putting that is like, I'm a McLuhanite, like the medium is the message, like the technology is the message. And if we build these systems that only allow for centralized operations, we're only going to get centralized operations on them.
Yeah, exactly. It's another argument for making this a distributed system in the first place. And my last question for you, Austin, and we'll do another one of these at some point for sure, is how has the founder life been treating you? What are the things you didn't expect? What are the things that have surprised you? What are things that have changed in your life? How are things going?
It's both easier and harder than you think it's going to be. Right? Like the hardest part. So first off, I don't know how anyone does it solo. Like I think the biggest advice I can give people is get a co-founder, because doing it solo is just incredibly, I like having gone through it with 2 incredible co-founders, like it would have been 1,000, like not 3 times harder, like 10 times harder solo. And also just like the way you have to build companies nowadays is so professionalized that like, no one has all of that in their head. You need people from multiple perspectives coming into to working on it. That being said, the other flip side of it is like, it's like going to the gym. Like, there's no one to keep you accountable but yourself. And so there's a lot of like self-discipline that goes into being a founder. One of the things I didn't expect was how much not like important but non-productive stuff you have to deal with as a founder. Like,
just shovel shit, baby. That's the number one founder job. Shovel as much shit as possible.
100%.
No one else
right?
wants to do it.
Like, it's really funny because like in some ways, like, yes, there's like a whole visionary component of being a founder, but in some ways it's almost like you're like a janitor for your employees. Like, most of our job is like provide strategic direction and vision and like make it possible for the very talented people you've hired to do better work. And like, if I can make them 15% more productive by like dealing with this other thing, like, that's actually probably the most plus EV thing I can do, because you multiply that 15% times 10 employees and like suddenly that's twice as productive. So there's a lot of stuff like that.
And people don't realize that you don't have an HR department at the beginning. You have to spin up a new Gmail for every new employee, or close a Gmail down for everyone that gets terminated. There are all these operational things that need to be done, and that's actually falls on the founder's lap, which is fun.
Yeah, I will say though, like I will say, like, David McIntyre, like this was the first person I asked. I asked him like, hey, do you have any ideas who would be like a good COO for the company? He was working with me at Solana Foundation at the time, and I was like, there's no way he's going to want to do this. But he was like, how about me? And I was like, oh, incredible. And like, I'd say, get yourself a COO who excitedly slacks you. Like, big news, I refactored the entire database for how we're keeping track of this thing. And like, here's it. It's so much better now. And like, I am not a spreadsheet person. Like, my brain does not work in that way. But like, it is incredible what a good COO can do to unblock all these types of things.
100%. Well, we'll do another one of these, Austin. Thanks for coming on, and have a lovely rest of your day.
Thanks. You too.